tells you everything you need to know. You got 3 speakers here talking about novel therapies for organic acidemias. 5 years ago, that was unthinkable. So it's really a terrific. Let's see if this works. A terrific opportunity to be here and share some of this stuff with you. They insist on calling these conflicts of interest when you're in academia, but when you're in front of people who need therapies, these are called opportunities. So thank you to all of the companies up here who have become interested in rare diseases, and I'll talk to you about some of those as we move along. So here's the biochemical pathway where most but not quite all of you fall. It starts with the amino acids, leucine, isoleucine, and valine, and it comes down here to methylmalonic acid, propionic acid, or propionyl-CoA more correctly, to methylmalonyl-CoA to succinyl-CoA. And this is a critical entry point for a cycle that generates energy and leads to secondary energy dysfunction in cells, and thus there's actually not that much difference from across the hallway here, because if you had been over there this morning when I was talking, you would have heard me talking about the TCA cycle or the Krebs cycle. Now, I have to geek out on you for a minute here because I want to talk to you about where these therapies are in the scheme of biology, and it's important for me to go back and to review something that is standard biology if you're in 6th grade now, but back when I was in 6th grade, it wasn't even known. So this is called the central dogma, and it describes how the DNA in your cells makes translates its instructions into you. So I think you probably all know that our genetic information is in our DNA. You get it's encoded in genes, and you get those DNA in the form of chromosomes from your parents, and you pass them on to your kids. And that DNA contains information that is able to program the cell to make proteins. It does that by taking the information on this DNA double strand here and turning it into a molecule called RNA through a process called DNA transcription. So it makes an RNA copy of the DNA. That RNA has a bunch of stuff that shouldn't be there called introns, and that gets spliced together just the way you would with a wire, and it makes a full coding protein. That coding RNA, excuse me, has all of the information to make a protein, which is called translation. So we have problems in the DNA, a change that leads to a problem in one of these processes, or a change in the protein that makes it not active. And we can intervene at a whole bunch of these steps, and you're going to see some examples of that. Excuse me. The most the one that I'm going to start off with is a project that I've been working on with some folks in the room from Moderna Therapeutics. And this is a messenger RNA therapy, and they're working on this for methylmalonic and propionic acidemia. So 2 of the more common disorders, all picked up, of course, by newborn screening. Now, they have a much more simple version of this that they provided me, DNA to messenger RNA to protein. And if your protein isn't working, if we can give you the message that makes that normal protein, then we can your cells can now start making that. So they have developed a technology using RNA is very unstable. It's made in the body. It's broken down very quickly. They have a technology that they can use to make RNAs that are stable, that once they're in your cell can make protein for a longer period of time, And that then, if it's an mRNA for MMA,